presenting these webinars. Anyway, with that being said, let me introduce today's presenter from Trend Micro, and his name is Mark Nonikoven, and I might have messed his name up. That's a tough one, but I hope not. Mark, if you want to go to the next slide and maybe people can see who you are. There he is, Mark. So Mark, is it Nonikoven?
Yeah, perfect. Thank you, Alan.
I got it. Okay. So Mark is Vice President of Cloud Research, and you can see his Twitter handle there. And he's going to be, I think he has some great insights today that we're going to be sharing around hybrid cloud and security and so forth. So Mark, if it's okay with you, I'm going to hand it over, and let's hear what you have to say.
Absolutely, and thanks for having me today, Alan. I really appreciate it. And thanks everybody for joining in. I think you're really going to enjoy today's session. It's very different than I think what you're used to, because we titled it "Handling the Realities of Hybrid Cloud" for a very specific reason. As we know, with DevOps, with the push into the different way of doing solution development and building applications, this has caused a lot of cultural challenges and a lot of soft challenges within our organizations, as well as the technical ones. So today we're going to look at all of those. It is a broad topic, but I really wanted to give people an overview of what's going on, as opposed to just saying, take this miracle tool that's full of rainbows and unicorns and it's going to make your life easier. What we're going to do is we're going to dive into the reality, and why I feel I'm a good candidate to talk to you about this is before I joined Trend Micro, I was in the Canadian federal government for a decade plus, dealing with security across organizations, with data centers, with a number of traditional, what you would consider traditional enterprises. So I've lived and breathed that world for quite a while. And about 5 years ago, I would say I was liberated into the private sector and able to work in a different way. So there was a really exciting project that a friend of mine asked me to come help with at Trend, and I've been working in the cloud full-time ever since. So I've had the opportunity to work with companies around the world tackling this exact problem. And I'm not sure if this is good news for everybody, but pretty much every enterprise and every large organization out there is dealing with the problems that we're going to be talking about today. So I don't know if that's a good thing that we're all in the same boat and we all have this problem, or if that's a bit on the negative side, but I think it's a positive, and I think after today we'll have a little clearer idea of some of the techniques that we can use, some of the strategies that we can employ to try to make sense of having a hybrid cloud environment. So where do we get started? And basically, the reactions to cloud range all over the map. From the super excited, CEO gets on stage at a main cloud service provider's event and screams from the top of his lungs or her lungs, "We're all in on the cloud." And everyone gets really excited, and it's a major move. And you figure, okay, that's great. They're moving everything into the cloud. That shouldn't take long. As you snicker under your breath. And that's sort of the one extreme, and it leads to the others where some customers or some clients want to sort of tiptoe into the cloud, and they just start with some experiments, some low-risk stuff, or maybe they move some development and test environments in. The point is, at some point in your organization's internal discussions and reading what's going out there, checking resources like devops.com, and learning about the cloud, you make a choice to start moving assets in there or to jump in with both feet. But even if you're what I would say is a best case scenario or the most excited scenario, and you want to go all in, it doesn't happen overnight, because you still have this major investment in a data center. And of course, the data center never actually looks like this, but as a complete sidebar, if you want a good chuckle, especially for those of you who are trolling away and working in a data center day to day, go look at a stock photo search for data center, and I have yet to ever see one that looks like that. Everything's neat and orderly, every cable's labeled, all this kind of goodness. But it's nice to live in that reality. But regardless of if your CEO is saying, we're all in, it's still going to take at least 12 to 18 months to move your assets in there, and that's optimistic. That's assuming everything goes smooth. So the reality is, even for the most advanced customers, for the advanced organizations who are diving into this stuff with full senior level support, you are still going to be dealing with multiple environments for a number of months, if not years. And the reality is, the vast majority of the rest of the organizations who are taking a measured approach into cloud are going to have multiple environments for multiple years. And the reason being is data centers are big investments, right? Normally you're dropping millions of dollars in to stand these up. and they tend to be on a life cycle of 5 to 7 years for most of the internal equipment, right? So that's outside of the physical lease of the data center, but all your switching infrastructure, your storage arrays, all this equipment that you're building and you're buying for your data center has a specific lifespan. And if you're in the middle of that lifespan, it's really hard as a business to step back and write that off because you're moving into the cloud. The savings in the cloud, you can save money moving into the cloud, but not enough to justify writing off, $15 million worth of equipment that still has a number of useful years left in it. So this raises a bunch of other questions as well, now that we know this reality of having multiple environments. So basic things like, how do you manage 2 or more of these environments at the same time? And that's at all levels, so process level, tools, just simply having a data center or multiple data centers and living in AWS or Azure or GCP. This is a challenge for your organization. Do you use existing processes that are slower than what we're looking for, right? So we read about a lot of the culture change and a lot of the process and tooling change on DevOps.com and from examples from community events, and you see how much faster and different things are working. Well, you already have established processes in the data center. Do you stick with those? Do you change them? That's a really tough question to tackle. How hard do you try to break down internal silos, right? So I'm sure most of us on the webinar today and watching this on demand afterward have probably read The Phoenix Project by Gene Kim. If you haven't, great book, pick it up. It's all about the transition to DevOps, and it paints a really rosy picture, and Gene did a really good job of phrasing it and kind of giving you the examples and what people have to tackle, but I think it was a little too positive and a little too sunshine and rainbows for the fights of breaking down existing silos in the data center. The question you're going to be faced with is how hard do you fight and which battles do you pick? How much is this investment going to take as far as making the shift? And which tools do you use? Do you use a unique set of tools for each environment? The data center is already established. You've already got assets there. You're already doing work there. Are you going to use that tooling and try to make it work in the cloud? Are you going to use a different set of tools completely in the cloud, or is there some other way forward? So these are all really, really difficult questions, really broad questions. Why don't we take a little time and we're going to dive in and get a little more specific, and we're going to take a little closer view at the actual challenge of having multiple environments. So we've got our data center, we've got our cloud. For the purposes of today's discussion, we're just going to keep it to one and one. Everything we're talking about, techniques, tools, ways to approach this, is going to work in multitudes. So if you have multiple data centers across the world or multiple clouds that you're dropping into, all this stuff still applies, but I think for the purposes of today's discussion, it's a little easier just to boil down into one and one. So we've got a data center, we've got a cloud, and it might look something along the lines of this. So we've got assets sitting in both. What you'll tend to see is the division of assets depends on how long your organization has been sitting in the data center. So very few people have the luxury of what some startups do, where they're starting from scratch, which is great. It'd be nice to be able to, take a nice clean Visio diagram or Lucid chart and diagram out your architecture from scratch with no legacy constraints, no legacy technology. I think all of us would love to be able to do that at least once in our careers. But the reality is we have an existing set of applications and services that are running in the data center, and we have new ones that are standing up in the cloud. So because of that timeline and that sort of chronology, what you're going to see is a lot of the foundational stuff is still sitting in the data center. So things like your directory services, so if you're running AD or some other LDAP, your directory services are probably still sitting in the data center. A lot of your core data in database services, well, regardless of what tooling you're picking, most of your data is probably still sitting in the data center. A lot of legacy apps, a lot of hidden surprises. Almost every data center I've visited around the world sort of has that rack of shame in the corner. It's a bunch of old boxes. It's sort of like a mini computer museum, and when you ask around, nobody's really sure what that rack is doing, but the lights are on and it's beeping, and the last time it got disconnected from the network, a bunch of people yelled, so you just kind of leave it there and let it sit. So it's great that it's working, but it's still something you have to deal with. So you get all these intricacies and sort of this interesting sort of anthropology or archaeology in the data center of how your business has changed over time. Whereas when you go to the cloud and start moving into the cloud, you're going to see new assets being spun up there. You're probably going to see any new application within the last year or two is probably started purely in the cloud, and it's starting to leverage different services in the cloud regardless of your cloud provider. So again, all this advice applies equally to AWS or Azure or the Google Cloud Platform or any other major cloud provider that you happen to be using. So newer stuff tends to go out there, and you may be starting to take advantage of some additional services, maybe something a little more abstract than infrastructure as a service. So you're starting to look at like machine learning or mapping APIs or something that provides real additional value that you can't replicate in the data center. So you've got this diverse little split. And anytime that you're standing up a new application, or dealing with an application, you kind of have this decision to make, and it ends up being sort of one of three choices, where you can have an application that rests entirely in the data center. So this is a lot of your legacy applications, but new applications may end up being pushed into the data center and staying in the data center for a number of reasons. Maybe they have to connect to a significant amount of legacy applications. Maybe they were off-the-shelf software that you purchased from a third party and it needs to drop in into your data center environment. There could be any number of reasons, but you have this category of applications that is sitting purely in the data center and doesn't have any connection out into your cloud presence. The reverse can also be true and is becoming true more and more often. This is the go-to, and a lot more organizations I'm encountering are setting down that rule, which is a really good one if you haven't said it already, is that everything new goes in the cloud. Right? Take advantage of all the tooling, all the shift and work we've done to adopt a DevOps mentality and drop it in the cloud, because the structures are there to enable this sort of collaborative and iterative flow. So you're going to be taking advantage, you're far more likely to take advantage of things like continuous integration and deployment when you're in the cloud, blue-green deployments into production. You're also going to be applying security very, very differently in the cloud compared to the data center. And we no longer have this hard wall perimeter. Security is now going to be applied very close to the workload and very close to the data. Your day-to-day ops is also a major shift, right? And this is the fundamental core of the DevOps movement. We're looking at more sharing responsibility amongst the teams. You code it, you fix it. You code it, you get paged, not me at 2 in the morning because you made the mistake. Let's get you to fix it. But this also creates a better team environment, and the team is a much broader skill set of team. This is for the DevOps.com crowd. I don't really need to explain this fundamental shift, but the cloud provides the technologies that enable this. So when you have a pure cloud application, that's something we're all comfortable with and we know how to deal with, even though it's very, very different than what we're dealing with in the data center. And that is sort of the fundamental problem of the hybrid environment, is that we have night and day, we have apples and oranges between these two areas, and we have good reasons to deploy into both or to maintain both given our current investments. So there's a third way to deploy applications, and this is where everybody starts to get a little itchy. They start scratching and then get a little nervous. Maybe you're grinding pulling on the armrest a little bit more, grinding your teeth, is when an application sits between both. So we talked a little bit earlier about having some fundamental and foundational services in the data center simply because that's where they've always lived. So things like your Active Directory, things like your core database services, and core business data living in the data center. So when you have assets or an application that's split across these two environments, all of the process and tooling challenges of the hybrid environment really jump to the forefront, simply because your application bridges both of these and you can no longer blissfully ignore the other environment. And this is really the crux of what we're going to be talking about and trying to address today, is how do you, as an organization, merge these two environments from a logical or process flow, even though they're very distinct and very, very different. It's sort of like trying to race in a race, but you're running a three-legged race when everyone else is a sprinter. So you're sitting there tied to your buddy, and everyone else is sprinting. The sprint is the cloud. The three-legged race is sort of bridging across the two. Or you can think of it, an easier way maybe is the data center is a car, and your cloud is a rocket. So in the data center, you are used to, it's reliable, you know how to figure things out, it'll get you from A to B. The cloud's a little more exciting, it's a little faster, you're going to get there faster, there's a bigger margin of error, there's a larger impact of a mistake, but there's a huge reward as well, there's a massive upside. So it might be useful for those of you who haven't dealt with the realities of a data center or the realities of a cloud for that matter, is to dive in and see some of the core cultural but also the core process and way of working in each of these environments. And it's really hard to actually convey that to people who haven't dealt with it. So if you've been lucky enough to be living mainly in the cloud and building solutions in the cloud, it can be a little jarring when you see and sort of get the idea of how things work in a data center. But I'll do my best to try to convey it to you. So a few core tenets of working within your data center. Tends to be an extremely high level of rigor. Okay, data centers have been around for a really long time. And we have a good set of processes, a good set of reference material around how to build data centers, how to run them, how to build each layer within them, so how you should be working for core switching, how you should be creating perimeters for security. All of this stuff is compiled, and you're probably familiar with the standard for it. It's the Itil Framework. It's a library of processes around change management, incident management, all of these things at a good level of rigor on how to work and operate IT within a data center. So that's a good thing. That's not a bad thing. The challenge that we face within the data center, though, is that a lot of people have lost sight as to why you take these actions and why you go forward with these types of things, and they just sort of start to do these processes by rote, and at that case, that's when we start to get into some challenges. Unfortunately, most things in the data center, they're primarily manual. So if you need a new switch installed or a new route into the network or a new subnet stood up, a lot of this is manual work. So there may be some automation at a really basic level, but it's a manual request to somebody. They are going to then evaluate that request. They need to make sure that it fits into the rest of the infrastructure, into the concept of the data center, and then after it gets approved, it's going to be done. So it's very much a process. It's very much manual. It's the complete opposite of the API-driven cloud. Again, as I mentioned a little bit earlier, these data centers tend to go on a 5 to 7 year life cycle. So this is not inexpensive equipment. As we know, when we shift into the cloud, everything's on-demand billing. In the data center, it's not. You need to either buy or lease this equipment, which means you're forecasting that total cost of ownership over a 5 to 7 year life cycle and saying, if I spend $100,000 on this switch, I'm going to be able to get you 7 years of lifetime out of it, and we'll start to reevaluate it in year 6. And there's a whole process, and there's a whole sort of dedicated methodology around managing the life cycle of all these assets in the data center. And again, that's not necessarily a bad thing. It's just we know there's maybe a better way of doing it. And of course, all this has led to what everybody loves to deal with, these massive silos. So there is a team for networking. There's a team for storage. There's a team for the database. There's a team for the virtualization layer. There's a team that manages your OSs. There's probably a team actually that splits under that manages Windows, and another that manages Linux. So there's a team for everything, which may or may not be a good thing. More often than not, these teams are in their own little silos. They have their own work plans, they have their own way forward, and it can lead to a challenge. So that gives you a glimpse of how things are run within the data center today. And this has worked for us. This has gotten a lot of applications up. There is, hundreds of thousands, if not millions of applications running around the world in data centers, and people are doing a really good job of that. So it's not all bad. It can just be a challenge when you compare it to the cloud. So the cloud also has a higher level, a good level of rigor. But the difference here is that code is enforcing that process and that rigor, right? We're all trying to shift to a continuous integration or a continuous development-like environment, and now we have systems that are enforcing these processes, as opposed to people manually going through these different things. Everything's highly automated, right? That's one of the things we all love about the cloud. An API will get you anything, which is great because it allows for a lot of rapid innovation, a lot of quick testing, everything that we know and love, and that's, again, ties to a shift in how resources are allocated. It's on demand. When was the last time you had to worry about capacity in any case more than, do I have an API call limit, right? My provider will only let me spin up 20 new instances or virtual machines unless I give them a call first, or fill in this form. And of course, once you fill in that form, now you can launch thousands if you want to. It's not a problem. And this sort of shift in the on-demand resources, you don't have to plan them out ahead of time, everything's highly automated, it's shift to this collaborative workflow that we've tagged as DevOps as a community and are really working towards to making sure that it's that everything's more agile, everything's more iterative. We're biting off smaller chunks and trying to deliver them. So very stark contrasts between these two environments. So when we step back a second, now, when we're looking at trying to look at the way forward, we're trying to reconcile our car and driving along these roads to our rocket and plotting a path into the stars. Right? So even going beyond, if you want to take the cloud metaphor, even beyond that. So it's two very, very different things. The data center is very established. People are very comfortable with that way of working. And as we all know from living it and breathing it, in the cloud, it's pushing a lot of boundaries internally. It's changing the way a lot of people think about delivering applications and about delivering solutions and even working together. Right? It's a lot more collaboration, a lot more teamwork, which I feel is a much better way of getting the job done, and probably you do as well if you're a patron of DevOps.com. So when we dive in and look at workflows, and I think that's gonna be a little bit that's gonna be helpful for us to see this process so that we can get to start looking at solutions. We're gonna start with the data center, and we're gonna see how a workflow is, and everybody's favorite silo starts popping up. So if we are the app team, so imagine yourself, we're trying to build a new application, we're trying to deliver some new functionality to the business. And we start with the concept and we kind of map things out and we go, okay, we're going to build a basic end-tier application, that is going to allow us to contact customers, and they can purchase or reorder very, very quickly from us. So pretty straightforward e-commerce application. In the data center workflow, we as the app team are going to figure that out, we're going to design it, we're going to pick some technologies, and we're going to start to pull that together. But when we get to the point where it's, what we consider done or ready for production, we have to go to each team individually to try to get the resources we need to stand up this application. It's very much a literal team-to-team application of sort of waterfall methodology. We go to the network guys and we say, we need this networking, we need these subnets, and we need this separation between our layers. The virtualization team to get the operating systems and the servers that we need. We go to the OS team to make sure that they can manage and bring these on board and monitor them correctly. We go to the database guys, we do the same thing. We get them to provision whatever data backends we need, and we get to the security team and we ask them to make sure that everything is safe and secure and that they're able to monitor it in the way we want. So it's very much a step by step by step by step by step all the way down, and sort of everything that we don't like about how the data center works, but it's well established and it's delivered consistently, even if it's much slower than what we're used to. Looking at each team, though, we see even more of a problem when we're trying to unify this, because every team tends to have their own processes. So the network guys are going to have a different way of allocating new subnets and new networking space, very different than the database guys if they want to spin up new databases and things like this. And you may have one unified way in front of it, the good old change ticket, but every one of these teams that's doing the work has their own way of working. They also have their own specific delivery timelines. Right? So they have their own set of work, they have their own work queue that you probably don't have that much visibility into, and they're marching along to their own time, to their own beat, right? They're off there on their own drummer, they're working on their own stuff at their own time, and they all have individual tools to implement this. So you'll see a wide variety of capabilities from these teams. Maybe your network guys are really on the ball and they can deliver you what you need in a few minutes, whereas the database guys may be getting slammed and it may take a few days to get what you need from them. And maybe the OS guys have automated everything. Maybe they haven't, and most likely they probably haven't, or they've got a bare level of automation. So there's really a mixed bag here, and that is a huge challenge to deal with because of the diversity of every team. Now when we flip over to the cloud, and as we've already established, everything's completely different. We're going to take the same perspective. We're going to look at, as an app builder, as a team who's building an app, what we would do. And in this case, I know I'm a lot more comfortable with this, and probably you guys are too. We're the app team. We sit there and we go, okay, we still need all the same components. We still need networking address. We need networking space. We need operating systems from the virtualization. We need server allotment or compute allotment. We need data storage. We need security. We need our OS, and we need security at the OS as well. So we've got a little bifurcation of security. But all of these things are accessible to us through automation. So we can get our networking space through an API, right? We can get our instances or servers spun up through the virtualization API. Same with the data, and same with the fundamental security for those areas. This is what AWS and Azure and GCP have brought to us, right? It's a simple API call, or even, if you're just getting started, you're going through the one web browsing management interface, and there's a lot of hand-holding to get this up and running. But basically, after a couple clicks or a couple API calls, you've got everything you need. There's a unified delivery time, and that's really an excellent way forward. Similarly, when it comes to a little more hands-on work, like managing an operating system or the security at the OS, app, and data level, we have new tooling. We have orchestration tools in place. So we've got things like Ansible, like Chef, like Puppet, SaltStack, anything or homegrown stuff that you've pulled together. We've added this level of automation and orchestration, and now we are set up as basically self-service or on-demand to build our application. Very, very different than what we saw when we were in the data center. So this, for our summary of our tooling here, is everything is accessible via an API orchestration, and even those orchestration tools are normally available via an API. So it's switched to an on-demand delivery system for us. We're not waiting for individual work queues. We're no longer concerned about how much work the DB team has or how much network addressing space is still available or things like this, because that's why we're going to our cloud provider. It's their job to worry about all of that stuff and hide it from us. That's great. That's a win. I know I don't like to worry about things if I don't have to. If I can push it off to a third-party provider, that's the huge advantage of the cloud and why we're getting there, right? The cloud is a massive amplifier of IT talent. Why not take advantage of it? And a huge thing that I don't think a lot of people realize is just how much the impact of that common tooling or common API layer gives you as far as freedom. You have a huge amount of freedom because you got one way of talking to multiple teams now. So the real question, and this is really going to get into the meat now here, is how do we combine these journeys, right? So yes, it is very, very different, but two very, very different environments, but we can work on making it easier to address them more like one logical whole. And before I dive into this, I know some of you are probably sitting there going, well, isn't there a big push behind private cloud in the data center? And yes, there is. Thankfully, data center teams are, they're very good at what they do, and they do, try to advance technology, move things forward. And a lot of vendors and tooling have been putting effort into creating that sort of on-demand self-service internally. The problem is it's not just about tools, and those tools are limited in scope as well. So, a lot of self-service and private cloud on the virtualization layer. It still has challenges around databasing, around storage in general, around networking, though we're getting better with software-defined networking. So it's not just about the basic push to private cloud, even though that is a good start. We still have a lot of challenges around process and around making sure that this is a unified approach. So like anything, as soon as you start to make cultural changes or even tooling changes, you're going to start to hear some excuses. And I'm hoping at this point a bunch of you are nodding your heads and going, oh yeah, we've heard a bunch of common objections, and some of them seem reasonable, especially when you're not familiar with the challenges that they are facing or the possibilities of getting around those challenges. So common things you're going to hear when you go to a data center team and try to start making big changes within the workflow to maybe line things up better with cloud, is you're going to hear, well, we can't automate it, or we can't provide self-service. A lot of the times, unfortunately, that can be true. A lot of these enterprise technologies were never designed with self-service in mind. So core switching is a good example. That's why there's a big push towards software-defined networking. Because if you have a core switch setup, it's based on a very static network structure. And to add new network segments and to allocate new network space, there's a process for it. And that process is very much manual with lots of checks and balances to make sure that there's still stability there. But a lot of the times when you dig deep, you can provide some level of automation or some level of self-service to the other customers, and the customers being you, the app provider. So you're also going to hear, no time, too much work, I got a bunch of other stuff I got to do, there's no way that I can allocate enough time to get the automation in place to start to meet these things, because everything is working now and I have all of these assets and all of this massive amount of computing that needs to continue working. We can't just drop the ball and go and start to integrate a new way of working without allocating enough resources to keep the lights on, right? Other thing you're going to hear, too many conflicts. So one thing you'll notice about a data center, and this ties into the Itil process, and if you're not familiar with Itil as a term, if you've heard of change management or dealt with a change advisory board, a CAB board, you're living in an Itil world. So it's just this structure and framework around things like change management. You're going to hear that there's probably too many conflicts. There's too many challenges to get the dynamic environment that you're looking for, or the on-demand resources are going to create too many conflicts with the rest of the data center. And that's because the data center has traditionally been looked at as sort of an integrated fabric of services layered on top of each other, where when we look at cloud, it's very much built from the ground up to be multi-tenant, to be isolated between each tenant, where the data center is more of a single tenant there. And it does create a lot of conflicts, but you need to start thinking in multi-tenant terms and in isolated terms so that you can provide this new way of working. Otherwise, your assets that you've invested in the data center, for however many years you're still going to be using them, are just going to be a drag, or they're going to be underutilized. And if they're underutilized, you might as well just not have them. So when you start to tackle process, and I know I've talked a lot about process today, and because it's critical, it's absolutely critical. It's not an area that a lot of us like to dive into. You know, a lot of us are more comfortable behind a keyboard, typing away on the console or working with technologies. When it comes to process, though, it needs to be addressed, and it needs to be addressed up front. It's one of the first things you need to start looking at. And start of the goals you're looking for here is to create a self-service environment. So we have that in the cloud by default. And it's not something you necessarily think about too much, but if you needed to start into the cloud today, say you've never been in AWS or in Google or in Azure, and today was your first day dealing with cloud technologies, the only thing you need to get started is a credit card. A credit card and an email address will get you up and running. That's pretty amazing. That's a really high level of self-service, especially when you contrast that to what we walked through in the data center, whereas if I want to deploy my new app, I have to talk to about 5 or 6 different teams to get things running. So what you want to big problem. When you have multiple timelines that are dependent upon each other, you can't move as fast as you need to. So if you get to the point where you're ready to roll out your application, and in the data center someone says, well, wait a minute, you don't have the database allocated yet, it's going to be another 2 or 3 days. That process needs to be somewhat independent. So you need to make sure that these sequenced or linked and required prerequisites are not breaking your overall application deployment. That's a really tough thing to do, but it's something that everyone needs to be at the table to talk about. You also need to work towards solution isolation. So we talked about this in the multi-tenant versus single tenant. It's absolutely critical that the data center starts to be thought of as a multi-tenant environment with isolation between these solutions. So they can be provided from a shared service, but if they're not isolated, they come back to this timelines being linked. And you want to start to automate a lot more of this rigor. So the change control and the processes that Itil brings to the table are really good things, but they can also be almost completely automated. In the data center, they tend not to be. There tends to be a lot of manual oversight. You want to get them to the point where they are in the cloud, where we've got CI and CD making sure that these things are all being met. So we're not losing a level of rigor. What we're doing is we're taking it away from people who tend to take time and can make mistakes, and we're giving it to systems which are there available on demand. If the mistake is made, it's an automated mistake, and it's the same mistake, and it's consistent, and it's easy to account for and to rectify. So there's where we want to start looking at for our processes. Then there's two main areas that I want to address before we dive into some tactics, and I'll give you a couple key takeaways that even if the rest of this kind of didn't hit the mark for you, these key takeaways are going to be good enough for you to get started to make sure that you've got a unified approach to dealing with your multiple environments. But before we dive into that, it's important to look at operations. So when I talk about operations, I'm talking about the running of your infrastructure, the running of your operating systems, the running of your security, the running of your applications, right? So what we would think of as standard getting this stuff up and going and keeping it healthy. So critical to these hybrid environments is having some level of visibility and mapping that covers both of them. You can't treat them as two different environments. You cannot treat them in two different tools. You need to see the overall logical footprint that you have across multiple environments. It's easier said than done, but it is possible, and we'll give you some tips in a minute on that. You want to make sure that you've got the same level of tooling or the same tools themselves for troubleshooting regardless of the environment. There's nothing more frustrating than being in an ops role and trying to troubleshoot a problem and going, well, I troubleshoot this web server in the cloud through method A, and this one's in the data center, method B. Because every time you do that, you're making it harder for your teams to keep up, you're giving them more to learn and more to take on, and you're doubling their workload essentially. Which, last time I checked, I didn't get double the budget because we started to move into the cloud. It would be nice if you were in that boat and got double the budget and double the team because you moved in the cloud. Maybe send a message to everybody on the webinar so we can all chat and figure out how you did it. But the reality is that most of us are dealing with limited resources and limited time. So having less tools is better because every tool you bring on board has an additional overhead. Same with logging and analysis. You want to make sure that you've got one central place to put your logs in. I'm going to tell you right now, it's in the cloud is way easier, simply because capacity is no longer a problem. You don't have to worry about that, you just need to pay for it, and it's far cheaper to be storing stuff at scale in the cloud than it is internally. But that gives you, again, one place to go to look at all the logging and to see what challenges are there. You also want to make sure that Ops has got similar levels of access in a similar method to the resources they need. So the good news here is that we want them to have less access lower. We want them to have access to tooling. So think to continuous integration and deployment. You don't want people logging into specific servers. What you want them to be able to do is to get the information out of those servers through unified logging and analysis, and then you want them to be able to update those servers with a new build in a blue-green deployment really, really quickly. But you want to apply that level of rigor and that sort of level of tooling into the data center as well. And you want to make sure that any tools that you're providing operations are capable of scale, both in size and in timing. You're going to see this repeated again on the security slide, but for ops, there's a big difference in operating a data center where it takes a month to onboard a new application versus in the cloud where I can stand up 10 or 15 new applications, or new deployments of an application within a day, all right, and you're continuously deploying. Your tools need to be able to take that into account. So here's the security aspect. Very, very similar because ops and security, while we've traditionally viewed them as completely different things, they really need to be the same. And as much as I love DevOps as a name, as a label to attach on this stuff, and I get it because it does describe the core, there's a lot more involved than just the development team and the ops team. The security team, the biz team, and the project teams need to be involved as well. But I think dev, biz, proj, sec, ops just isn't nearly as catchy, and it would make for horrible, horrible URLs. So when you think DevOps, think devops.com, but also think about all the teams involved, especially security. They need to be operating in the same way. So that ties to visibility across environments. This is similar to the operations, but from a security perspective, visibility is at a bit of a different level. What we're concerned about in security is normal operations and the delta from normal. So if everything is running at capacity and that's normal operations, security is not concerned about that. What they're concerned about is that if every web server should be at 10% and one is running at 100% CPU usage, that's a bit of a concern for security, because is that an operational failure, or is that a malicious attacker or actor trying to take advantage of the environment? So visibility for security is slightly different than operations because it has that different viewpoint. You're looking for delta from the norm. Big key and really, really difficult thing for security when you're talking about hybrid environments is that the controls need to be independent from the environment. You can't have a specific set of controls in the data center and a different set of controls in the cloud. You want to make sure that the same controls in each, because you are applying controls based on the risk to the data. So if the data merits that it needs to be encrypted at rest, it should be encrypted at rest regardless of where it is. If the data is important enough or the app server is critical enough that it needs intrusion prevention, which here's a little pro tip, all web servers and all servers really should have intrusion prevention. You want to make sure that that control is independent of the environment. And that's a big shift from the perimeter defense in the data center to the on instance or on virtual machine defense that you need in the cloud. And unified logging analysis, very, very similar to operations. In fact, here's a great way to get the teams working together and build one massive logging and analysis platform or leverage a service available in the cloud. And again, you need the capable of scale, both in size and time. For security tools, this is where a lot of them fall over. Traditional security tools were built under the concept of that things dropped into the data center at a very slow, sedate, and predictable pace. Having a server that exists for 10 minutes was not something that most tools were designed around. So you want to make sure that you've got tools that are capable of that sort of scaling, both in size and timeline. And here's where we first mentioned responsibilities. You need clear responsibilities and ownerships for security, and the reason for this is when there's a security incident, you need to know who to talk to. You need to go, who to go help, who to work with to make sure that things are being resolved. And this extends beyond your teams. This extends to your cloud service provider and to any third-party SaaS services or cloud services that you're leveraging as well. You need to know where things are and who's responsible for them, so that who you can go talk to when there is an incident. You don't need to be scrambling around when you're under attack or you're dealing with a security breach to figure out who owns server A or who owns instance A, or what service, what the contact number for our third-party ERP services or things like that. You need to understand all this stuff up ahead of time. So those are some broad strategies where we're shooting for. I'm going to give you finish off here on some tactics that you can take away and how you can apply these things. So we're going to start back with our asset view. And one of the things I want you to come away from this talk with is an understanding that you want to take tools from the cloud and start to push them into the data center. And I say this because all of our cloud native tools, so our CI/CD stuff, our log analysis, a lot of our security tools that were built cloud first in mind, all these tools that we've designed to handle the cloud are now becoming more and more capable of handling the data center. Now, the reverse is not always true. A lot of data center tools are struggling to deal with the reality of the cloud world because the fundamental principles that they were built around don't line up with the cloud. So we've mentioned it a few times already with that sort of slow, sedate pace of change in the data center is in stark contrast to the rapid iterations and self-service in the cloud. So it's much better to take your cloud tools, try to adapt them to go into the data center. That can be tough, but you're seeing it more and more from the major providers. A lot of their services are now working off the cloud and in data center or on physical locations, but you need this because it is going to get you where you want to go. You're going to be shooting towards your target tooling, which is very much how we work in cloud, very much a DevOps principle. So you're going to start, easiest place to start from my experience is going to be with orchestration tools. So your Chef, your Ansible, your Puppet, Salt Stack, that kind of stuff. Very simple to bring into the data center. Also not very controversial or very challenging to bring in to the operating system management teams. They love that kind of automation. Another thing you're going to try to do, we mentioned it a few times, can't harp on it enough, is try to automate the data center infrastructure. That could be challenging depending on your investment. The cheat, and you will get pushback on this, is to pre-provision a bunch of things. So instead of having custom on-demand saying, I need a new set of network segment or a new database or new storage array, pre-provisioning these within reason and using existing demand to sort of forecast that pre-provisioning can really help speed up the process. Again, unified logging, asset mapping. You may get some pushback from security on this because they don't like logging data leaving the data center if they're used to that sort of walled perimeter. This is a battle worth fighting. Get your logging and asset mapping, get it unified, get it pushed up into the cloud. And again, consistent security controls. You want a consistent level of application, ideally the same tool applying security in the cloud and in the data center. But if you can't get the same tool doing the same thing, you want the same controls reporting their events and monitoring into the same tool. So if you can't get the same actual control, getting the similar control eventing to the same place is a really good way to do it. So in addition to tooling, you really want to nail down the responsibilities. So you want to make sure that it's clearly defined who has operational and security responsibilities. Remember, when it comes to the cloud, that's a shared responsibility with your cloud service provider. The good news here is that most of the cloud service providers have clear documentation, especially around security, as to who does what. So they will say that they will protect for a virtual machine in the cloud, they will protect everything up to the operating system level. The operating system, the app, and the data is your responsibility. But these need to be clearly defined so that you can understand so that where the gaps are, where the challenges are, and when things happen, you need to understand what the service level agreement is. Now remember, and this is a huge pet peeve of mine, service level agreement is not something to be, you're not shooting for that level of service. You're not trying to achieve that. You're not trying to attain that. A service level agreement should always indicate the worst possible case. You want to always be beating an SLA. So if somebody says they're going to respond to an incident within 4 hours, that should always be the worst case scenario. That team should always be trying to respond as quickly as possible and be as helpful as possible. So it's not striving for an SLA, it's it was a bad day and we met our SLA at 4 hours as opposed to the normal 20 minutes that we responded to. And this includes your external providers. Bit of a bad news on the external provider side, especially with the major 3 cloud service providers. It is extremely rare that you will be able to negotiate any sort of custom terms. You know, the only example that I can really point to would be the CIA in the US, and they bought themselves an entirely dedicated, isolated region from AWS, so they were able to dictate terms, but everyone else is dealing with the common shared multi-tenant cloud. These technologies work for the cloud providers because of the commonality, so they don't tend to negotiate custom SLAs. They do offer different packages, so you can pay for premium supports and things like that, but it's not like a traditional environment where you could negotiate with your data center provider for specific terms. Process. You want to look at the cloud first process, so everything in the cloud, the way you're doing it right now with DevOps, so that's the good news. You're already in where you want to be. The challenge is making exceptions in the data center, and you want to make sure those exceptions are as small as possible. You don't want to be making massive exceptions for the data center. That's why we talked about bringing the data center more into the way of cloud, more the way that it works. You're going to get pushback. This is a fundamental change to how people are working today and how they've worked for years. Be empathetic, but also make sure you stand your ground. Consistency is key for the business. It's absolutely crucial that you have consistent process across all of the environments that you onboard. The last one we're tackling is security. You want to make sure you're looking at security as a unified layer. Data is data regardless of where it is. If you're protecting customer personal information, so PII, or if you're PCI compliant or dealing with healthcare information, all of this data is the same regardless of if it's sitting in your data center or if it's sitting in the cloud. You need to look at security as a unified layer based on what the data dictates, not on where it is. So the tools will change or the controls will be slightly different given on where it is. So if you're dropping something into the cloud, you don't have the opportunity to secure the network layer or the virtualization or the physical stuff, but you're relying on your cloud service provider to do that. So you need to make sure that your security tools are integrating with the cloud service provider. So this is, making sure that it's keeping up with the pace and the speed. It should have some sort of access to your cloud accounts. Remember that the traditional perimeter is gone. We used to apply security based on like the castle principle, right? Everyone's safe in the castle. We've got these big giant walls and a moat and a drawbridge and all this great stuff around the perimeter. That's not true anymore. The perimeter is long gone. We have to defend very much at the workload, at the data level, and that's very, very important. And there are tools that will let you do that in the cloud. Those tools also extend and let you do that within the data center as well. You need to make sure that you're looking at security as a unified layer. So your 3 main takeaways for here. You're going to be aiming for one set of processes. Now, it's really, really easy for me to type this in as a one bullet line on a slide. So I did that. So there you go. Aim for one set of processes. I'm going to dust off my hands and I'm done. No, I'm not going to leave you like that. But what it is realize that this is your goal. This is a goal that's going to take a lot of work. This is a goal that's fundamental to DevOps in the cloud, and you know how tough that's been getting people on board of working in the cloud. It's even tougher when you try to unify the cloud and the great work you've done there with the data center, because it is so it sits in such stark contrast to how the data center works today. Make sure you're pushing cloud tools to the data center. It's very rare that you want to do the other way, simply because the cloud tools are normally highly scalable, they're really dynamic, they tend to have more modern user interfaces, and more importantly, they tend to be really easy to get data in and out of, as well as highly automated. So a lot of them have APIs. That's why it's absolutely critical to push those tools inward. And you need to make sure that security is a unified layer. If you're looking at security by the environment versus by the data, you're going to open yourself to unnecessary risk. Above all, please remember, this stuff is hard. This is really, really tricky because it's a lot of soft stuff, it's a lot of process, it's a lot of people who like their environment, who are used to working a certain way. You're going to be pushing a lot of buttons. You're not going to get this right the first time, but you got to keep working on it. Work together, try to iterate quickly, and you should have success. So with that, I think we're going to open it up for questions. As we're waiting for those to come in, if you have questions for me, you can ask now. That'd be great. We'll get a nice little discussion going. Otherwise, you can reach me on Twitter at markn.ca. You can learn more about the culture, process, all the great tooling available that we're used to in the cloud at devops.com, which of course all of you already knew. From a sponsor perspective, I work for Trend Micro. We've done a lot of great work with cloud security. You can find out more about us at trendmicro.com/AWS or /Azure. For both of there, we have free trial of our software platform that will help you protect and tackle the hybrid cloud scenarios. So with that, I think, Alan, we'll kick it back to you and open it up for questions.
Great, Mark. Thank you. Hey, that was actually a great presentation, Mark, on a subject that I think is really important to people. People who know that it's not all or nothing when it comes to cloud. We're all moving some stuff to the cloud, and eventually more and more of it will move. But, in the real world, these things take time, and there are transitions, and there are everything else. So I appreciate, tackling the subject, Mark, and I think you did a great job. We have a few questions coming in here, but I got to tell you the truth that the overwhelming comments are thank you, truly excellent presentation. So kudos to you, Mark, for, as I said, for doing a good job. While we're waiting for some questions coming in here, though, Mark, let me ask you a question. When you talk to customers, right, real live people who are living this now, what do you see? Is security still the big boogeyman inhibitor that it was, let's say, 5, 7, 8 years ago?
It's becoming less so. And I think that's mainly just on education. So, we've all been through this process, and we saw when cloud first started getting popular, boogeyman is very much a good term for it. People kind of freaked out and said, no way am I going to trust my data to, this third-party cloud provider. And I think, we've been working on the messaging from the vendor side, from the community side, from the service provider side, to try to get people to understand. So it's coming up less and less, but I think it's much easier to address now. So the easiest way to address this, and for those of you that are listening, if you're concerned about security in the cloud, the simplest way to understand the current state of it, basically, is to go to your provider. So go to AWS or go to Azure or go to Google Cloud Platform, their main website /security. And each of them have, a listing of all of the third-party validation, the compliance with, any number of, the acronym soup that none of us understand half of them, but all of these validated, reputable auditors. So one of the big 5 auditors, like an Ernst & Young, or KPMG, has come in and audited their operations to ensure that any of those initial sort of hype and negative questions about security have been answered and addressed. And once you understand that these cloud providers sort of live and die on their reputation, so it's in their best business interests to be as secure as possible, and that's all they're looking at is operations and security. Once you understand that that foundation is ultra secure, and that your responsibility is to secure, for infrastructure services, at least the operating system up, it becomes a much clearer picture, and a lot of people kind of step back and go, oh yeah, my initial concerns or sort of freak out wasn't really merited. This is a much clearer and a much simpler way to proceed with a really high level of security.
Great. So here's a question from the audience, Mark, and that is, and I'm going to paraphrase after I read it, so give me a sec. What are some logging monitoring tools on the cloud that you can use from the data center? And it brings up the question of people don't want to use two sets of tools, a cloud tool and a data center tool. They're really looking for solutions that bridge. And this is particularly for logging and monitoring. That you can use both in the cloud and data center. Any suggestions?
Yeah, absolutely. So there's, I'll say right off the bat, there's a lot of vendors and a lot of people actively playing in this space. So there's a lot of stuff you can go and any major event you can go and kind of look through. But some basic ones to get started. There's some really good open source ones out there that will help. So the Elk stack is always a good choice. A Logstash, little agent that sits on your OSs and starts dumping stuff out. It'll go into Elasticsearch and Kibana, sort of that whole. That's the Elk. It's the Elasticsearch. Logstash Kibana gives you a really good way of visualizing this data. You want to make sure you've got a robust storage or data structure behind it, so a lot of good file storage. Things like Monet and Negos are open source tools that you can drop on your systems to start monitoring them. But I think the big difference here is to understand that when we monitor in a data center, we've got way more visibility and a lot of different devices. So you're getting logging information and maybe packet flow information from your routers, from your switches, from the storage network, from all this kind of stuff, and you lose some of that visibility when you go into the cloud. So the number one thing you're looking for, and this is why a lot of the open source tools tend to be really good at, is you're looking for flexibility in a tool that will allow you to ingest a bunch of different formats without a huge amount of overhead. So there are standardized like syslog or JFlow or any of the flows for packet data formats, and then a lot of the stuff in the cloud is logging as JSON, which is great. So Elkstack, Negos, Monet. On the commercial side, something like Sumo Logic or Splunk are really good tools to help start to get in there. There's a ton of activity in this area. You kind of just have to Google around and see what is going to best suit your needs. But all those tools will handle both environments quite nicely.
Got it. You know what, I think, unfortunately, Mark, we're at the top of the hour, coming up on top of the hour here, and we have a kind of good, strict policy about we respect people's time. So I think we're going to call it a wrap on this webinar. Mark, many thanks to you for, as I said, an excellent presentation. Thanks to Trend Micro for sponsoring today's webinar on hybrid cloud, and thanks to all of you for joining us today. Until next time at our next DevOps.com webinar, this is Alan Schimmel for DevOps.com. Have a great day.